Inaction here. So good evening, everyone. My name is Jeff Geist. I'm on the board of ANGE, which is the Alliance for New Jersey Environmental Education. Thank you all for joining tonight's session. The following presentation was developed by Sea Change Conversations, which is a Princeton-based nonpartisan volunteer staff nonprofit dedicated to fostering productive conversations about climate change. Sea Change was founded in 2014 by Kathleen Biggins. And as a Garden Club of America member, Kathleen was inspired by going to national affairs and legislation meetings in Washington, D.C., and saw how many people were talking about climate change. And then after returning back home, realized that it wasn't really being discussed as much as she was hoping it would be. So today's speaker, Dallas Hetherington, met Kathleen back in 2018 when him and his wife went to a Garden Club of Somerset Hills meeting. And after the presentation, Kathleen Biggins asked for volunteers to help kind of spread the word. And Dallas volunteered and has stuck around now for a few years. So Dallas is now retired after a 31-year career in the chemical industry. And today, in addition to being an approved speaker for Sea Change Conversations, he monitors local bald eagle nests near his home in New Jersey, enjoys wildlife photography, investment management, and serves as the president of the board of trustees for Raritan Headwaters Association, which I know a lot of us are familiar with. They're the leading New Jersey water quality watchdog. So Sea Change Conversations has presented today's presentation on climate change to audiences in over 31 states and to over 16,000 people. The presentation is going to take about an hour, and we have a lot to cover. So what we're going to ask is that you either hold questions until the end, or you can submit questions in the chat as we're going through, and I will filter through them kind of as the presentation's going, and I will relay them to Dallas at the end. So Dallas, I'm going to mute myself and I'll turn it over to you.
Fantastic. Okay, sorry. Are you able to see my screen?
Yep, looks good.
All right, really good. So, hello everybody. Whenever we begin this presentation, we think it's really important to start by addressing three facts that aren't often enough discussed, but that I think that we can all agree with. The first is the fact that everyone knows that the climate has always been changing due to natural causes. Yet, scientists say that after a remarkable period of stability for the last 10,000 years, humans, through our activity, are triggering a period of remarkable instability. And we're doing this at a time when there are about 7.7 billion people on the planet, with close to 10 billion projected by mid-century, all wanting higher standards of living, and we can't just pick up our tents and follow the water and food resources as they react to a changing climate. The second is the fact that fossil fuels have been such great friends to us. They have given us a vibrant economy and a remarkably high quality of life. But scientists say if we continue to use them in the same way that we have in the past, they'll actually do the opposite, decrease our GDP and hurt our quality of life for ourselves, and especially for our kids and our grandkids. The third is that this is a tough topic to talk about. It's often viewed through a political lens, even though the polls show that most Americans understand that climate change is happening. And a strong majority understand that it's being influenced by human activities. Where we tend to disagree is how we evaluate the severity of the risk. For some, it's an existential threat, propelling us to an apocalyptic world that will damage our economy and endanger our children. For others, it's a tempest in a teapot, a reason for government expansion and overreach, and for taking actions that will make America less competitive and puts polar bears in front of people. And the majority of Americans, though, fall somewhere in the middle, wondering how concerned to be. And that's why we work with scientists and energy policy experts to develop this Climate Change 101 presentation, to provide an accessible overview of the science and clear-eyed projections of the potential consequences, so that all of us can feel better equipped in assessing this risk. And we've divided this presentation into 5 parts, answering the questions most Americans have. What are those questions? How do we know it's real? How do we know it's us? What do scientists think? Is it dangerous? And number 5 is their hope. We're going to spend most of our time there. Let's all dive in together. So first, how do we know that climate change is really happening? Well, the basic physics of how climate change works has been well understood for well over a century, and it is in fact really non-controversial. So let's go over it quickly to refresh. This is how it works. The sun's energy comes through the atmosphere and hits the planet's surface. Some solar energy is absorbed, but much of it ricochets back off towards space at a different wavelength. Some of that ricocheting energy is partially captured and re-radiated back towards Earth by the greenhouse gases, which make up less than 1% of our atmosphere. These are primarily carbon dioxide, methane, nitrous oxide, and water vapor. Without them, we would have a frozen planet. But when we create more of them by burning fossil fuels, they simply capture more energy, warming our planet more. Another way to look at this is in terms of the carbon dioxide cycle, which is how nature stores carbon dioxide between the Earth, the oceans, and the atmosphere. As we burn fossil fuels, we're taking carbon that nature has sequestered deep underground in the form of bits of plant and animal matter over hundreds of millions of years, and we're pumping it back into the atmosphere at the alarmingly fast rate of over 40 billion tons of carbon every single year. That's much faster than the rate at which nature would be adding it naturally. We're upsetting the old balance. And scientists have been measuring it every day around the world at over 10,000 sites. And then they overlay satellite data. And 5 independent agencies, including NASA and NOAA in our country, analyzed this data. And they all reached the same conclusion, that our temperature has gone up 1.2 degrees Celsius, or about 2 degrees Fahrenheit, from pre-industrial times to today. Now, that doesn't sound like a big change, but as we'll see later, a small change in average temperature can change how we experience living on the Earth. So don't be fooled by small numbers. Small numbers matter. How else do we know that this is real? Well, scientists are observing it all around the world. Take a look at this NOAA graphic showing how ice is disappearing from the Arctic Ocean. This shows the older ice, which is white, leaching out of the ocean and melting away, being replaced by open water and immature ice, which is depicted in dark and light blue. As you can see in this time series, which runs from 1990 to today, we're losing vast amounts of white mature ice. And this is important because the white mature ice was very reflective. So when the solar energy came in, more of it got sent back out into space. This white ice acted like a windshield reflector, protecting the Earth, and scientists say we've now mostly lost that protection. So now the whole region allows more of the sun's energy to be absorbed by the Earth, further pushing up our temperatures. And we can observe it with our own eyes too, like in these pictures of the Muir Glacier in Alaska. This is taken from the exact same place, the same time of year, but about 60 years apart. Looks like a totally different planet, right? Glaciers are melting like this at an alarmingly fast rate all around the world. Another way that we know climate change is real is because we can look back in time and we can see how today is different from the past. Paleoclimatologists can, among other things, pull up ice cores that are 800,000 years old. And in those ice cores, there are little air pockets trapped by frozen snow. Those air pockets can be analyzed for carbon levels, among other things. And what do these paleoclimatologists tell us? They tell us that we are in uncharted territory. We have more carbon dioxide in our air today than at any point in the last 800,000 years, when CO2 parts per million oscillated naturally between about 150 and 300. This was through the natural cycles the Earth goes through, from ice age to thaw. In 1910, we broke out of that natural pattern decisively and crossed 300 parts per million. And according to NOAA, in April of 2021, we reached 417 parts per million. This increase occurred 100 times faster than what normally happens in nature. And yes, it was higher early this year as well than the 417. And scientists say if we continue on our current emissions path, we could reach almost 1,000 parts per million by the end of this century. So let's move to the second question in our presentation now. How do we know that it's us? Well, we know that we're putting lots of carbon in the air by burning fossil fuels. In fact, we've got 43% more CO2 in the air than at pre-industrial times. And we know that adding greenhouse gases into the atmosphere will warm the planet up. But how much is nature doing versus man? It turns out that CO2 molecules produced by burning fossil fuels have a different chemical fingerprint. So scientists can actually determine which ones were put there in the atmosphere by human activities and which ones are there through natural occurrences. So we can see our impact. In fact, scientists have analyzed the things that naturally impact our temperatures, such as the Earth's orbit, its tilt and wobble, solar activity, reflectivity, and volcanic activity. And when they put all those influences into the climate models, we get this bright blue line on this chart, which show that we would be in a very slight cooling period right now. But when you add in our activity on top of the natural occurrences, you get the bright green line. And look how closely it approximates the orange line, which is what's actually been happening. This suggests that 100% of the warming is due to human activity. Scientists simply cannot explain what they're observing without factoring in our influence. Okay, so let's move to question number 3 in our presentation. What do scientists think? And this is a very important question because only about 20% of Americans understand how strong the consensus really is. In fact, it is as strong as the consensus that cigarette smoking leads to increased incidence of lung cancer, something I'm guessing most or all of us on this Zoom call might accept. We may hear a lot of numbers thrown around in terms of scientific consensus. We also see the skeptical scientists highlighted in the press. So we looked to an organization that we felt we could trust, NASA, to get their point of view. NASA says 97% or more of climate scientists say climate change is happening and that humans are influencing it. Perhaps even more persuasive is looking to prestigious scientific associations, ones that vote on and publish an official position. 80 national academies of sciences around the world and over 100 prestigious associations that we ourselves reviewed, including those listed here on the slide, all say climate change is happening, human influenced, and poses risks ahead. And by the way, our National Academies of Sciences issued its first climate warning almost 45 years ago. I'd like to ask you to think about how you evaluate risk in your life. If you're like most of us, you divide risk into 3 parts. The first part is how likely is it to happen? Well, we just heard that 97% of climate scientists say it's happening, and we just saw the Arctic melting away. So I think we can check that first box. Yes, we know it's happening. The second part of that risk assessment is, what are the consequences if it comes to pass? And do I want to live with the consequences, or would I much rather avoid them? The third part of the risk assessment is, how difficult or expensive is it to avoid the risk? I hope you would agree with me that that's a good way to look at risk. If so, then let's jump into the second part of that risk assessment, which is what the consequences could be, and are we comfortable living with them if they indeed come to pass? And this brings us to question number 4 in our presentation. Is it dangerous? I think this could be the most important slide in the entire presentation because it shows the big picture. Let me take a second to orient you. On the y-axis, we have temperature in Fahrenheit, ranging from 9 degrees Fahrenheit colder to about 11 degrees hotter. And then on the x-axis, we have a timeline from 20,000 years ago to modern day. The yellow line is the average temperature with milestones superimposed on top of it. So back 20,000 years ago, we were still in an ice age. There was a mile of ice on top of Manhattan. Clearly, our climate at that time was very different. Much of the Earth as we know it was uninhabitable. But over about 8,000 years, nature moderated and the temperature rose to what's been the average global temperature more or less for the last 10,000 years, about 60 degrees Fahrenheit. And that's been a very good temperature for our species, as it turns out, one that the Earth hasn't often been at during its long history. And here you can see this appeared on the slide where agriculture emerged and we began to create our civilization. And then a little bit further along, you see another small increase in temperature where the Vikings were able to farm in Greenland during the medieval warming period. And then there's a small dip down, maybe 1.5 to 2 degrees. And that represents the Little Ice Age in Europe, when glaciers began to advance, causing hardship, food shortages, and social upheaval. As you can see here, small changes in average temperature can mean a big difference in how people experienced life on Earth at that time. And then the line goes vertical, with experts projecting that it's going to land somewhere between 3.6 degrees to almost 11 degrees Fahrenheit warmer by century's end, depending on what we choose to do. So think about it. What's life on our planet going to look like if the average temperature on Earth increases that drastically? And that's why almost all 196 of the countries of the world came together at the Paris Accord in 2016 and said, we can't go there. They said we need to keep below the 3.6 degree Fahrenheit mark, which correlates with 2 degrees Celsius, a number we hear in the press a lot. Or even better, a 1.5 degrees Celsius goal, because at that lower level, we can probably mitigate, adapt, and be resilient enough to handle what's coming at us. Above that, we become much less optimistic. So let's drill down on what these changes could be to our natural systems. But as we go through these changes, I'd like you to consider them through 3 lenses. How will they affect our jobs and local economy? How will they impact our health and personal security? And how will they impact geopolitical stability, which we can experience as refugee crises, civil chaos, and even terrorism? Now, why are we looking through these 3 lenses? It's because these are the 3 things Americans recently said are most important when they go to the polls to vote. We believe that climate change will affect all 3 in very negative and very dramatic ways. So let's see if you agree. We're going to start off looking at temperature and seeing how it's changed from pre-industrial times to today. This is another graphic from NASA, which shows how our temperature has changed from the pre-industrial period through 2020. When the color is blue, it's colder than normal. White is average, yellow is warmer, and red is hotter. As you can see at the end, the red came crashing in. And that's because we're not just breaking records, we are shattering them. Here's another way of looking at that, how far out of the normal range we've come. Notice first the steep rise in temperature over these last 50 years or so. And then I want you to note the last 6 years have been the hottest years ever recorded. Now that's the history. What does it mean for us going forward? In New York, it's going to be even hotter. An average of 26 different climate models predicts New York could be 9.4 degrees warmer in the summer by century's end, similar to today's summers in southern Florida, if we continue on our current emissions path. By the way, this is from the Climate Central website, which has some terrific interactive pages where you can get predictions for cities around the country. But heat is only part of the equation because humidity amplifies our problems. A day with a temperature of only 86 degrees can actually be deadly if humidity levels are too high, simply because our body's sweat can't evaporate to cool us off. Days that have a combined heat and humidity index of 90 degrees are considered danger days, when it's dangerous to be outside for parts of the day to work or recreate. All these cities will have more dangerously hot days by 2050, with the darker areas increasing the most. In general, by 2050, Northern Hemisphere cities are projected to feel like cities 600 miles to the south. New York City would feel like Virginia Beach, Minneapolis like Kansas City, Phoenix and Miami like Baghdad and Rio de Janeiro. And some of the best known southern cities like Orlando and Tampa will reach even higher temperatures for long periods of time, hitting a heat index of 105 degrees. A temperature that's beyond even what a healthy, fit human can handle for long periods of time. Why? Because when our body's temperatures rise past 104 degrees, think about a fever, we start experiencing actually damage at the cellular level. leading us towards things like heat stroke, when our organs can begin to fail and we can experience brain damage and even death. Okay, so now let's step back and think about those three lenses that I asked you to consider. What does it mean for jobs in the economy in those areas when for almost 6 months of the year it's considered dangerous to be outside? Well, we know productivity goes down as heat goes up. We know the crop yield goes down as heat goes up. We know some infrastructure buckles or melts in the high heat. And we know we'll need more energy infrastructure to cool our population. So none of this is good for jobs in the economy. And what about personal health and security? Well, higher heat increases crime, and excess heat has a wide range of impacts on our health, from heat stroke to increased cardiovascular and even kidney disease. In fact, heat is the #1 weather killer because more people die from heat stroke than floods, hurricanes, tornadoes, and other natural disasters. What about the third question, that geopolitical concern? Well, as hot as it will be here, it will be even hotter and much less habitable in parts of South and Central America. So experts expect we're going to have refugee flows against our borders to get to cooler climates. And intriguingly, they also warn we could have migration flows from our southern states to our northern ones. Let's move over to food production. Increasing heat is projected to impact food production. Food yield is projected to increase, shown in green, or decrease, shown in red, if temperatures go up by only 5.4 degrees Fahrenheit, which is significantly lower than our current trajectory. As you can see here, Russia and Canada will benefit for a little while, but as temperature continues to rise, there is no green left on this map. This means that our risk of global famine increases dramatically. And of course, food isn't just on land, it's also in the oceans. Climate change is making the oceans much more acidic as the carbon dioxide mixes with the ocean water. Now, this is deadly for sea life, including shellfish that we like to eat, and also for creatures at the base of the marine food chain, like these pteropods in the slide, or otherwise called sea butterflies. This is impacting the fish populations like salmon and mackerel, fish that we like to eat. 54% of specimens like these sea butterflies picked up off the coast of California in 2015 showed damage to their shells. And when scientists put them in water as acidic as it is expected to be by 2100, their shells totally melt away. In addition to increasing its acidity, we're also heating the oceans up. As this graphic shows, some areas are already 4 degrees Fahrenheit warmer. This produces stronger and more damaging hurricanes. These higher temperatures also lead to bleaching events for our coral reefs, which are the nurseries for about 25% of all marine sea life. Remember when we said that small fluctuations in global temperature really matter? This is a great example. Scientists say that if we keep the temperature increase to 1.5 degrees C, then 10 to 30% of our coral reefs might survive. But if we go to 2 degrees, they say we will probably lose all of them. So every fraction of a degree matters and is worth fighting for. And remember, over 3 billion people rely on food from the ocean as a source of protein. So again, huge potential risk for food insecurity and famine. Let's stick with water. Flooding from torrential downpours. It's happening more and more frequently. This is simply because warm air holds more water vapor. It's just physics. For every 1 degree Celsius, the temperature rises, the air can hold about 7% more water. So the more temperatures continue to rise, the more water is simply up there to fall down on us. As you can see, and as I bet some of you have noticed here in New Jersey, the increase in torrential rains is happening not only across the nation, but especially in the northern Midwest and the Northeast. Let's turn to sea level rise. Sea level overall has already risen about 8 inches since 1900. And this relatively small change is bedeviling communities up and down our coastlines, even on sunny days. And we know the rise is accelerating due to glaciers melting and the oceans warming, and so they're thermally expanding. NOAA's best case scenario is about 1.5 to 3 feet of sea level rise by the end of this century. Its worst case scenario is 8 feet. depending on how unstable the ice sheets become in Greenland and Antarctica. It's not just a question of how high, it's actually also a question of how fast this is going to happen. In fact, we don't know how much time we're going to have to react to this and what we'll be able to protect and what we'll have to let go to the sea. And the economic risks are big. Zillow projects $1.3 trillion of property will be lost in the US at a 6-foot increase. And that doesn't include additional properties that are at risk from storm surges, nor does it capture the cost of infrastructure that we'll lose, like the roads and the bridges and airports and railroads and fiber optic networks that hug the coastlines. That could easily triple these numbers, so exact numbers are very hard to predict. Moving to the topic of health, we've got an entire presentation on how climate will impact our health and personal security. So there's an awful lot that we could cover today, but we won't. So for today, quickly, some areas that the CDC maps out on its website include exposure to excessive heat, increased lung diseases like asthma and allergies, because climate change is causing pollen levels to increase. The three we want to focus on here briefly: disease from pests, more frequent and deadly wildfires, and an increased number of natural disasters. Diseases from pests like fleas, ticks, and mosquitoes are increasing noticeably. And this is because these pests are rapidly extending their geographical footprint and are active longer in the year. In fact, according to the CDC, illnesses from insect vectors tripled in the US from 2004 to 2016, tripled in 12 years. The risks from this include old diseases like malaria, which is expected to come back to this country someday, and new diseases for us like dengue, Zika, and Chagas. While the way we manage our forests plays a large role in forest fires, so does climate change. The much longer fire season, now 8 months versus 5 months, and the higher temperatures means more fires. These fires have far-reaching implications on health, of course, endangering those in the fire's way, obviously, but also spreading air pollution far and wide. Note that 5 of the 6 largest fires in California history occurred in 2020 and 2021. The Dixie Fire this past year, now the second largest California ever. And you're not imagining it. We are experiencing more big disaster events in general. This chart of billion-dollar disasters in the US illustrates it. The number of disasters has almost doubled since the 1980 to 1990 period, with the Red Cross calling large disasters our new chronic condition. Not every disaster is due to climate change, but scientists say it's loading the dice and stacking the deck against us, making them more likely to happen. In fact, the science of attribution has developed well enough that scientists can now say some of the most extreme events, including last year's unprecedented heat wave in the Northwest and Southwest Canada, would not have been possible without climate change. And again, it's going to get worse, not better, as climate change continues forward. The CDC says that climate change will lead to mass migration and international conflict as environments become more and more unlivable. And it's not just the CDC saying this. Military leaders across the free world, including our Secretary of Defense, are warning that climate change will fuel more conflicts and could cause catastrophic threats ahead. It's a threat with some pretty big economic loss projected too. According to the BlackRock Institute, these changes will have profound impacts on our economy later in the century. All the areas on this map that are not green, most of the country, in fact, will likely take hits to their economy by 2060. Swiss Re, the major reinsurance company, issued a report stating that the world could lose 23 trillion by 2050 in economic output, and that US GDP is projected to drop about 7% if we don't act. And earlier this year, Deloitte, there's an old line name, released a report forecasting that climate change could cost the US economy 14.5 trillion by 2070. And I'll come back to this Deloitte report in a few minutes with some better news. So I'm going to take a couple of moments on this slide to sum up this section. We can't leave out the great loss to biodiversity. I want to comment on that too. Climate change is compounding this. For example, the Audubon Society says that almost 2/3 of North American birds are threatened by climate change. And it's not just our animals, it's also our plants. Scientists say that the biodiversity of the landscapes could be lost to us. These beautiful trees are having to move north because they need more cold in order to survive. Now, today I've shown you things that have already happened. You can see with your own eyes, like the temperature change map that we saw from NASA and the glaciers melting away. And you've also seen projections from NASA and NOAA that are institutions we find credible and that we normally look to keep us informed so we can make decisions to stay safe. So do we think those predictions are perfect? Of course not. They're just projections. So much depends on what we choose to do as well. It's more about, are they directionally credible? And then the question becomes, when we assess the risk in our lives, do we wait until it's 100% certain that it's going to happen? When the consequences are so great? How many of you in the audience have fire insurance? We don't know that our houses are going to burn down, but most of us buy fire insurance and we close fire doors in our offices. We take these precautions because the consequences are so great. Yet scientists say the risk of climate change impacting each of us on this call is much greater than the risk of your houses burning down. We're simply not evaluating this risk correctly, the way that we would any other areas of our lives. And I know there's some people who say the current models are alarmist and overstate the risk. But what we don't hear in the press is that there's also a subset of scientists who say, actually, the models underrepresent the risk because they don't capture the black swan events, things that aren't yet well understood, but are catastrophic if they happen, like the melting of the Arctic permafrost. What's that? Well, we all know that when the plants or animals died in the Arctic, they froze before they decayed. And now as the Arctic is warming faster than any other part of the planet, they are thawing en masse and releasing huge amounts of carbon dioxide and methane. And methane is many times more potent than CO2. This additional methane could lead to a natural feedback loop, causing runaway warming that we could never control. And there are other potential black swans out there, but we don't have time to cover them in Q&A, perhaps, if you want. So today, we have a small group of scientists who say, hey, no worries, be happy. Some scientists who say, drink heavily, the Titanic is going down. And the vast majority of scientists are somewhere in the middle who say, this is a true threat, and there are smart things that we can do to mitigate the risks. And we are asked to make a bet, not just for ourselves, but for our kids and our grandkids and future generations beyond that. And we've got to ask ourselves, what would a prudent person do? Okay, I've probably really depressed you. So let's move right to the fifth question, which I think will help with that. Is there hope? And the answer is yes, there's hope. There's a lot of reasons for hope. We've boiled it down into 6 reasons why we have hope. The first is that the economic equation of addressing climate change has flipped over in recent years. Let me explain that. We as taxpayers are already paying for climate change right now out of our pockets because of all these natural disasters. And we're also paying to build infrastructure to try to protect ourselves from the new weather normal. For example, there's a $14.5 billion wall to protect the New Orleans coast. And there's a $125 billion harbor Seagate project that New York City is considering. And there's millions and millions of more that are being spent already to protect Miami and Norfolk and variety of places along our coasts. But while those costs are escalating as we speak, the cost of moving to a lower carbon economy has dropped so precipitously that it makes sense to address climate change whether you believe in it or not. As you can see from this slide from Lazard, on an apples to apples, unsubsidized basis, renewable energy is now the cheapest form of power generation today. Wind is the cheapest and solar is second, followed by gas, coal, and nuclear. That's before everything changed. The state is before the Ukrainian situation. So it's even in many ways amplified now. This is a game changer. And it's true already in 2/3 of the world, including the world's largest emitters, the US, China, and India. And it's expected to be universally true within the next 5 to 8 years. which is why almost all new power generation being built, 82% in 2020, is in renewables. And the US Department of Energy believes the cost of renewable energy, which is already the cheapest utility energy ever produced, can drop by another half by decade's end. Meaning the energy transformation already underway is likely to accelerate. And that means that it now appears possible to meet the energy needs of this country and still reach net zero emissions by 2050 with no increase in costs. A recent study came out of Princeton University mapping 5 different pathways. It's a fascinating study. I recommend it. Each emphasizing different technologies to reach net zero by 2050. Some included nuclear, some biofuel, some carbon capture, different pathways, different mixtures of approaches. But no matter how they configured it, it came in within the same budget for the energy sector as what is expected to be spent in the next 10 years anyway, about $9.5 trillion. All 5 pathways came in about the same. So the costs appear manageable. And importantly, additional new studies from the National Academies of Sciences show the transition will actually create more jobs than if we do nothing. 1 to 2 million more jobs over the next decade. And contrary to what's often quoted in the press, many of those jobs will indeed be high paying and dispersed widely across the United States, with net job gains projected in the majority of states. And remember, I mentioned the Deloitte study released earlier this year predicting economic loss if we don't act? That study also said our economy could gain $3 trillion in value over the next 50 years if we accelerate towards a path of low emissions growth. So there's a gold mine in front of us. A quote from that report says, the analysis shows that the battle to slow climate change is not only an aspirational goal, but an economic imperative for the United States. Let's move to the second reason there is hope. Other countries are stepping up and they're leading. Today, more than 110 countries, plus many states and cities in our country, have all pledged to be carbon neutral by mid-century. Together, these represent more than 70% of global GDP. Good news. And while Europe is taking the lead on a global basis, promising to be the first carbon neutral continent and apparently accelerating their transition due to the Ukrainian situation, many eyes are today on China because it's the world's #1 emitter with 28% of global emissions. And it's exporting a lot of dirty fossil fuel technology. But at the same time, China has been on a quest to dominate the new low carbon technologies, and they've been successful, leading the market now in solar, wind, battery technology, and even EVs. They've pledged to become net zero by 2060 and launched the world's largest carbon market last summer. Now, I'm sure that many people are skeptical that China will deliver on their promises, but we should remember too that China appears in many ways more vulnerable to climate change than we are. In fact, its highly populated manufacturing hub called the Pearl River Delta is considered the world's most at-risk urban center to sea level rise. And China's breadbasket, called its North China Plain, is considered one of the most likely spots for deadly heat waves. Not good for them. So maybe there's motivation. And beyond China, this detailed chart simply shows that the developing world overall, the green bars on the chart, don't read all the details, just notice the green bars and the blue bars and their relationship. The developing world in green has been spending much more on renewable energy than the developed world, shown in blue. That's good news. We need them. The third reason that there's hope, financial institutions are also stepping forward. Last year, we had 2 major institutions take stands on climate change, including the US Chamber of Commerce, which said that inaction is no longer an option and called on policymakers to create policy like a price on carbon to address climate change. And then also the Federal Reserve last November called climate change a threat to the stability of our financial system. And the SEC, the Securities and Exchange Commission, is now proposing to require public companies to report on their climate risk and emissions. Details are coming out on this, and there's going to be a battle over it, so we're going to watch how this develops. The investment community also is advocating for change. In a letter to CEOs in 2020, Larry Fink, CEO of BlackRock, the world's largest asset manager, said, climate change has become a defining factor in companies' long-term prospects and is causing, quote, fundamental reshaping of business. And many businesses are working to embed climate risk into their financial decision-making and to drive emissions out of their supply chains. In fact, almost a quarter of the world's largest public companies now have net zero commitments. This could have far-reaching benefits. And for the very first time, they have recently begun to lobby at the federal government level on policy action on climate change, which is a kind of a crossing of the Rubicon for many of them. Reason number 4, there is also hope in all the new tech that's on the horizon. If we update our grid system with existing technology to enable wind and solar to get to population centers and add storage, including technologies that are about to come out, including the new long duration batteries that are being promised, renewables could handle most of our load with current projections at 75 to 90%. And the infrastructure bill just passed last year includes, by the way, over 70 billion for grid enhancements. So that's good news. And once we have a clean grid and sufficient battery capacity, we've got to electrify everything: buses, cars, garbage trucks, as well as the heating and cooling in our buildings. But for the short term, as we transition to a low carbon economy, we're still going to need to use fossil fuels. So we have to find a way to capture and sequester the carbon emissions from those fossil fuels before they get into the air. This is a working carbon capture plant in Iceland. It captures and then pumps carbon dioxide down into basalt rock underground, and it turns the carbon back into rock, permanently storing it. Several companies are working in this technology on several continents. And of course, we already have so much excess carbon in the air that we also need to find a way to get it out, to remove it. And that's why this negative emissions plant has potential. It sucks carbon out of thin air and sells it to companies that use the CO2 to literally recycle our carbon emissions. Today, this is much too expensive for prime time, so it needs investment, which is happening. Many scientists also say that nuclear will have an important role to play because nuclear plants provide reliable carbon-free energy. The US was once at the forefront of next generation nuclear technology, but China is now building new nuclear plants rapidly and is projected to surpass the US in nuclear energy by 2035. This year, it signed an agreement with Russia to develop nuclear power together. And exciting to me, because I just saw a webinar on this, technical breakthroughs with materials, lasers, and artificial intelligence could potentially be bringing fusion, which has been called the artificial sun and long the holy grail, as a source of clean, safe, and limitless energy in reach within the next 15 years. The National Academies of Sciences, for the very first time, has called for the construction of the United States' first plant between now and 2040. Already, there are dozens of companies in this race, and many are saying that proof of concept will happen in just a few more years this decade, with commercial operation predicted next decade. If true, would be staggeringly exciting. Perhaps even closer at hand, though, is green hydrogen. There's no CO2 or methane from burning this, and you use net zero emissions energy to break apart water and create the hydrogen gas. This is important because it's got many potential applications in heavy manufacturing and transportation that straight electricity won't be able to address. So this could be a big win for us. This next reason for hope is that we now understand nature has great power to regenerate and sequester carbon if we help it. Studies show that better land management practices, including increasing reforestation, restoring wetlands, and advanced agricultural practices like no-till and cover crops can help as well. In fact, it's believed if we deploy this farming approach widely, land could absorb up to 30% of our excess carbon. That would be staggering if it were true. So we've got to try. This sixth reason for hope is that we have done something like this before. So maybe we can do it again. What I mean is that in the 1980s, Ronald Reagan pulled the world together to save the ozone layer by stopping the use of chlorofluorocarbons, CFCs. Some of you may remember this. Otherwise, our generation now wouldn't be able to safely go outside because of the danger of the UV radiation coming through the ozone layer. What we may not know, though, is that CFCs are concentrated, powerful greenhouse gases. If President Reagan hadn't acted, today we would be about 2.5 degrees centigrade hotter. That's amazing. So he and the leaders of his time literally preserved the world for us. And last but not least, something that may surprise some people, Americans are no longer as divided on this issue. If you ask Americans if they think we should regulate CO2 as a pollutant, 75% say yes. And if you ask Americans if they think we should be putting more money into renewable energy technology, 86% say yes. There are many different policy options too to address this issue, some appealing more to Republicans, some more to Democrats, and people in the middle. Many options being discussed today were actually developed decades ago. Our challenge is in finding the best way to fit solutions together as quickly as possible. And I say as quickly as possible because, as you probably have noticed, we're in a race for time, and today we're losing that race. As you can see from this graph, to stay within the safer temperature ranges, we need to cut our emissions drastically, and we need to do it immediately. Our current path is the top red line. This would bring us up to around 7.7 degrees Fahrenheit at the end of the century. And it's actually closer to 12 degrees Fahrenheit hotter on land because that 7.7 is an average of land and sea. Think about it. When our average global temperature was 7 degrees colder, we were in an ice age. What do we think our world could look like at 7 degrees hotter for our kids and our grandkids? I don't know about you, but I don't want them to have to find out. We simply must act now. So what can we do? What can we do? The first thing we probably need to all do is think about this a lot more and recognize the urgency of this issue. While Americans understand climate change is happening, only about a quarter of us realize how urgent the threat is and that we need to act immediately to protect ourselves and our kids. We need to recognize we're all in this together. What we do individually and collectively will either protect others or harm others because we are all in the same boat. And we have to embrace innovation. That's one of the things our country does really well, right? And renewable energy and LEDs and the new battery technologies are our ready-made weapons against this risk. And there are so many more technologies on the horizon. We need to put our investment and our focus on them. And armed with the understanding of all this, we need to influence our policy leaders, no matter where they sit on the political spectrum. It doesn't matter. We need them to work together to bring solutions to the table. We can also influence companies as an employee or as a shareholder or consumer. And they are driving so much of the change. We've got to educate ourselves. We need to avoid the pundits who are too often paid to enrage, and instead take a look at what the investment banks are writing, or the Financial Times, or the International Energy Agency. And I have more references. For example, there's a lot of good information out there. And then bring this topic back to public discussion by talking to friends, telling them your concerns, and discussing what you are learning. Let them know how many things around this issue have changed, that there are real affordable solutions out there, new technologies enabling us to make the changes necessary. If people understand those solutions are there, we'll go a long way towards getting people activated. And there are many more personal things that you can do to impact climate change on your own, just in your own home. Just as every fraction of a degree increase in temperature matters, every small action can add up. And this pie chart on the left shows the CO2 footprint of the average US household. as you can see, the biggest two sources are how we heat and cool our homes, shown in green, and our car and air travel, shown in purple. Making small changes can make a big difference. For example, buying clean energy from our utilities can shave about 6.5 tons off our household CO2 footprint. That's a lot of tons. You can do this now in much of New Jersey. And I know I can do it here in my hometown in Bernardsville. An electric car, another option, saves about 7 tons. Flying less, taking one fewer coast-to-coast round trip per person, almost 3 tons. And several other suggestions include like getting an energy audit for your house, buying energy smart appliances the next time you renovate the kitchen, using less plastic, eating leftovers, which we really need to pay more attention to because about 40% of our food is thrown away all across the US, and so much energy goes into producing and transporting it. Also, if you eat less meat and more locally produced food, this will help too. And then there's planting trees at home or in community spaces, and there's composting. And finally, consider writing checks to those organizations pushing for constructive climate policies. They are critical to creating the public and political will for action. In closing, we are the first generation to understand the risks of climate change. We are the first generation to understand that we are leaving an increasingly damaged planet to our children and grandchildren. And we're also the first generation to have the tools to address it. So the question for all of us on this call and all of us on this planet is, what will we choose to do? That's it. And here are some quick announcements before Q&A. If you enjoyed this presentation and think you might know a potential host for us, please contact me directly or contact us through the Sea Change Conversations website. Also, we depend on audience feedback, so please volunteer 2 minutes to answer our audience survey, accessible using this QR code. Also, tomorrow, you may wake up and say to yourself, that was really interesting, but what did he say? If you would like to receive an excellent brochure summarizing today's talk, send me your name and email address or contact Jeff Geist. We'll send you a colored PDF presentation summary and also the link to the audience feedback survey in case you prefer to do that then. Thank you again, Jeff Geist and Angie, for hosting our primer this evening. You are a pleasure to work with. And okay, that's the end of the comments. I'll remain right here to chat and answer questions for as long as you like.
Fantastic. Thank you so much, Dallas. This was a great presentation. I've been looking forward to it for a while. So there were a couple questions that were in the chat that came up, both from Laura. So first one is, have you given this presentation to groups that lean more towards climate change denial? And if you do, what point do you think had the most impact and has the best chance of changing their minds or leading to a change in behavior?
Great question. So Sea Change Conversations was founded by a group that is politically diverse. And they realized that what you're referring to, which is that many conservatives tend to lean more away, let's say, than liberals do or progressives do, lean away more from believing climate change or the whole story around climate change. In fact, the number one, the single question that you can ask an American that will give you the most information about what somebody believes about climate change is, what party affiliation do you have? So it's a highly politicized. So we look for conservatives and centrists as much as possible when we go out. And what we find is, because we present typically in a hosted scenario like this, that they'll come because they're invited, and they'll be polite and they'll listen. And yes, occasionally at the end, in my own experience, and I've seen it with other Sea Change speakers, we will have somebody who's really not happy with the topic at all speak up. And occasionally we'll get an angry individual. What we've learned is that most conservatives who come have an open mind, at least open enough to listen, and we usually get a good response from those people on our surveys. And what we've also learned, and this is valuable, particularly for me dealing with the people who are really, really negative about it, is that you can throw as many facts at people as you want, but it will typically not change their mind. And the way to, the most compelling way to reach somebody is to try to get to them on a human understanding level. And what do I mean by that? I presented to a hunting group a couple of months back, and I got to shoot with them, and I got to talking with some of them, and a couple of them came up to me and knew I was about to give this presentation and volunteered that one of them said I go to Texas, and another one said I go to Arkansas, and I hunt different. One was hunting quail, and another one was hunting some kind of duck. And I related to this because I did a little bit of this when I was a kid, and they said that climate change has changed where these animals can be found now. Their ranges are impacted. Their when they fly and where they fly when they migrate has been impacted, and it's really concerning to these individuals. So the point is that gardeners will have a gardening point of view. People who work on trees and will have a tree point of view, and hunters will have a hunter point of view. So trying to get to them on that, or people who own homes on the coast will have a flooding concern, right? So finding that commonality that somehow can tie us together is the most impactful way to not throwing facts at people. Thank you for that question. I hope I answered it.
Great. Another question here before we wrap is, if you were to guide students in one or two fields to combat climate change, what would you suggest they get into to make the biggest impact that they can? Is it technological development? Is it policy? Is it what does that look like?
That's a really interesting question, and I suppose it depends a little bit on of course, on the interest of the student, because somebody who's interested in politics is going to be different than somebody who's interested in the tech. What I can say is that the studies show that most of the jobs that are going to come out of this have to do with efficiency. So building efficient buildings, or especially taking old building stock that's out there and making it more efficient. The heating systems and cooling systems and all that. That's where most of the jobs are going to be. And then the rest are going to be in battery and wind and solar technology, which is, of course, growing like crazy. So those would be the top headlines that I'd like to share.
Awesome. Thank you. And then, so just to confirm, you'll be sending me the link to the survey along with the kind of summary sheet that I can send out to everyone. So you'll get that link again to the survey for the person who asked for it.
I'll get that out to you tomorrow in the morning, first thing, and then
that sounds perfect.
Promise.
Okay, sounds good. All right, thanks everyone. Thanks for joining. Thank you, Dallas, for doing the presentation. This was great. Thanks for supporting Angie and some environmental education initiatives. And we hope to see you again soon at another forum.
You're welcome. And if anybody has any additional questions, I'll take them by email. So everybody be well.
Take care. Have a good night.
Bye.